everyone. It's just gone 4 o'clock now. Well, it is in Ireland anyway. So I'm going to kick off this webinar. First of all, I'd like to welcome everybody. Today we have attendees from all over the globe, from every single continent. So you're very welcome, and thank you for joining us to Automated Distributed Data Centers with Controllerless, SDN and Open Networking, together with our partners Pluribus Networks. My name is Ciara McCarthy. I'm the Global Marketing Director for EPS. This is the 7th episode in our It's Open Networking webinar series. So you can access all of our past webinars and sign up for future webinars on our website. So the URL is shown on the screen there. And for anybody who doesn't know us, I'll just give a quick intro. EPS Global is an open networking solutions provider, and we work with customers worldwide. You can source your entire network solution from us. That's the hardware and the software, so in one place, and save yourself time and money, not to mention the hassle of dealing with multiple vendors and different delivery schedules. We've 28 global locations, so we're never far away, and we carry stock and provide technical advice and support for your implementation, which Barry will touch on later. So I'd like to also introduce our speakers today. So our first speaker is Barry McGinley. Barry's our systems engineer for EMEA. He primarily works on proof of concepts for data center, service provider, and enterprise deployments, and he leads the adoption of new bare metal hardware for carrier and telecom solutions available from the Cord platform in the ONF to backhaul projects within the Telecom Infra project. He provides the first layer of tech support to our customers with an in-depth experience in the open networking landscape, covering all of the open source software and hardware options. Barry's based in Dublin, Ireland, and is the author of a popular tech blog on our website at epsglobal.com. He'd like me to add that he's also an avid Celtic supporter and enjoys a pint of Guinness. Joining us today also is Mike Capuano. Mike is the Chief Marketing Officer at Pluribus Networks. With over 25 years in networking, including Pluribus, Infinera, Cisco, and Juniper networks, he has broad expertise across service provider and enterprise network architectures and technologies, including data center, edge, cloud, SDN, NFV, routing, switching, and optical transport. Mike is based in California, and we're delighted to welcome him today as a guest speaker. So finally, just a little bit of housekeeping. If you have any questions, just type them into the Q&A window at the bottom of Zoom. Barry and Mike will answer those questions at the end. And if there's any questions that we don't have time to get to, we'll answer offline directly with you. So with that, I will hand you over to the interesting people. Barry, I will hand over to you.
Cheers, Ciara. Thank you. And thanks, Celtic, got a mention. That's great. So as Ciara mentioned, I'm Barry McGinley, based in Dublin, and primarily working in open networking for EPS Global. So what we're going to cover today, I'm going to have a look at open networking, have a general overview of open networking. I'll have a kind of high level overview of an underlay and overlay fabrics and multi-site fabrics then as well. Mike will take us through private cloud trends, and then we'll have a look at the adaptive cloud fabric. So the controllerless SDN for multi-site. We'll summarize, and then we'll take questions at the end. So we've a bit to get through, so I'm going to push on. Okay, so Ciara touched on EPS and what we actually do in open networking. So we're around 21 years, but since 2013, we have been distributors for edge core networks. So that was our entry into open networking. But I think we realized pretty quickly in 2013 that the normal rules of distribution weren't going to apply here, and it was kind of twofold. So 2013, it was only hyperscalers that were deploying open networking. And then as well, hardware is only one part of the puzzle. So we had to go out and start talking to the software vendors, and not just some of the software vendors, all of the software vendors. We like to say that we're vendor agnostic when it comes to the software, so that we're not kind of pigeonholing a piece of software in where another one would do a better job. So we'd like to kind of simplify open networking for our customers. So I suppose looking in, open networking can be a bit daunting. So you might have 6 different operating systems, 6 different hardware vendors. You have hardware interoperability or hardware compatibility lists from the software side. You have interoperable optics, and so on and so forth. So it can be a little confusing. So we try to take that hassle away for our customers. We'll put on the operating systems, the licensing, bundling, transceivers. So basically switches are ready to slide into a rack. We also provide this service for our our software vendor partners as well. So we can decal boxes with stickers and labeling. And again, stick the NOS on, stick the licensing on, bundle in transceivers. So basically the switch is ready to slide into a rack when it arrives in the DC, which does take some of the hassle out of open networking. Okay, so open networking attributes and benefits. So most of you guys are going to know this stuff. So on the attribute side, we've open hardware. So we've white box, bare metal, and bright box. Bare metal is our bare metal box, and it has a bootloader called Oni on it, which allows us to put the NOSes on. We then have white box, which is a bare metal switch with an operating system on it. And then we have bright box, which is basically a bare metal switch with a different label on it. So that would be HP and Dell and companies like that. We have our open software. So we have open source and we have commercial. So Pluribus would be a commercial software offering. And then we've software controlled infrastructure, SDN, network function virtualization, automation, analytics, and so on. And that's more about what we're going to talk about today when we look at the adaptive cloud fabric. So the benefits, so the main benefit, first benefit I should say, is disaggregation. So removing vendor lock-in is important. Now we have a choice of the software and we have a choice of which hardware we put it on. We have greater control over our network infrastructure using SDN. So by the separation of the control and data planes, we can control our infrastructure much better. Rapid innovation through an ever-growing community, and that's kind of twofold. So that's people who have implemented open networking in their data center, and then also the kind of organizations that run open networking. So we have the Linux Foundation, the OCP, look after the hardware side. We have the ONF, the Open Networking Foundation, and we have the Telecom Infra Project. And both of them are kind of looking at the carrier and telco markets. Reduce CapEx and OpEx. So CapEx, obviously on bare metal, we're going to reduce our capital expenditure. And then when we move into the SDN side of things, we'll see how our operational expenditure will decrease. So the physical side of things, so merchant silicon is very important to bare metal. This is our switching ASIC, and we have Broadcom, Marvell, Mellanox, Cavium, and Tofino. Broadcom with the highest market share at somewhere between 76 and 90%. So anyway, a monster in the merchant silicon world. Multiple bare metal vendors. So we have EdgeCore Networks, Quanta, Delta, UfiSpace, Celestica, and these companies are primarily out of Taiwan. EdgeCore Networks is the leader in the bare metal switching world. The main switch has been sold today for data centers. We've 10, 25, and 100 gig. 40 gig was kind of skipped a little bit. People seem to move straight to 100 gig. So Trident 2 and 3 for our leaf switches, and then Tomahawk 2 and 3 for our spine and super spines. And they are Broadcom merchant silicon. We've moved into the telecom space since 2016. So there's two organizations there. So the ONF, the Open Networking Foundation, started a project called CORD, which is Central Office Re-architected as a data center. And then the Telecom Infra project again started in 2016. So the 3 different project groups. They have one for access, so it's your RAN, then backhaul, which is from your cell tower back to your data center, and then core and services. So between the two of them, they have a bunch of projects that have reference designs and actually are in production networks now. SIBA, software-enabled broadband access. I think Turk Telekom and Deutsche Telekom have implemented that. Trellis is spine and leaf, so like a fabric within the central office. Comcast have that in their production network. And then we have OOPT, which is the Open Optical and Packet Transport, similar to ODTN that the ONF run. And that's the white box Cassini transponder from EdgeCore for backhaul. And that's actually implemented in a bunch of different networks. Again, Broadcom are kind of big in this space as well. So the chips I mentioned, Trident 2 and 3 and Tomahawk 2 and 3 are from the XGS chipset, but they released the DNX chipset, which some of them are called Qumran AX, Qumran MX, Jericho and Jericho 2, and Ramon, and they've been very successful in that telecom space. So just a quick graph for you. This is from Omdia's Data Center Network quarterly call, just to give you an idea of bare metal and where it's going. So I think we're around here now. So we're just about 30% of all ports shipped. But then you have to take the the bright boxes into the equation there as well. So when we do, we're actually up over kind of closer towards the 60% mark of ports shipped. And one of the other important parts there is the maturity and availability of options for switch NOSes continues to improve. So that is quite important. So on the telco side, it seems like nearly once a month now there's a new NOS coming out that may have been in the middle of a proof of concept for a year, 16 months with a tier 1 telco. But then the maturity side is really important for the data center. So Pluribus are 10 years old now, have over 300 large implementations worldwide. Cumulus are over 10 years old. IPI are 20 years old. IP Infusion, Pika 8 are more than a decade old. So they're not new companies and they're not startups anymore, which kind of helps assuage anybody's worries, I suppose. So very briefly, I'm going to go over Underlay, Overlay, and Fabrics because it'll help us when we get to looking at the adaptive cloud fabric. So the underlay basically is the actual physical devices. So our switches and routers. So here are switches, routers, and cables is our underlay. IP connectivity is done through layer 3 protocols. So BGP, eGRIP, OSPF, so on. It's responsible for delivery of packets. And the underlay is hardware orchestrated. And now the overlay that we're going to look at is software orchestrated or virtualized. So the overlay sits above the underlay. So this is our underlay here. And our overlay is the virtual network formed on top of our underlay. And the way it kind of works, this is quite a high level overview now. So say we have 2 switches, say we have that switch to that switch. We have on the switch ports are called VXLAN tunnel endpoints, so VTEPs. There's, oh, sorry, go back there. So there's one at one end and one at the other end. One does the encapsulation and one does the de-encapsulation at the other end. Each VXLAN network is given a VNI, which is a VXLAN network identifier. It's similar to a VLAN identifier. So with VLANs, we had 4,095 possibilities. With VXLAN, it's 24-bit. We have 16.7 million possibilities. So you're not going to run out. So you can imagine with VLAN, you have 500 companies, say you can give them 8 VLANs each before you run out. So the packets then are transmitted, encapsulated with the VTEP, sent over the VXLAN tunnel, and de-encapsulated with the other VTEP. Multiple overlays can run through the same underlay for multi-tenancy, and that's quite important when we look at multi-site. Okay, so very briefly, we'll look at fabrics. So we've got 4 spine switches here, and we've got the pole just popped up there. We've got 48 leaf switches. So each leaf switch attaches to a spine switch, and it kind of forms this woven crisscross pattern. This is where we get the name fabric from. And why do we require fabrics, or where do they come from? So the proliferation of east-west traffic, basically. So before, when we used the 3-tier hierarchical model, we had a core, a distribution layer, and an access layer, and traffic was coming in our core, down to a host, and back up out the core. That's not the way traffic is moving anymore. So traffic is moving more around the data center. So east-west traffic from node to node. VM, we need it for VM migration and containerization requirements. So allocating resource to spin up containers quickly. And then what we're going to look at actually, the ability to create one logical data center over multiple sites, which is what we're going to look at when we look at the adaptive cloud fabric. So the benefits, we have scalability. So if we're oversubscribed, we add a spine switch. If we need more port density, we add a leaf switch. Really simple. More effective load balancing. So each leaf switch can go to any of the spine switches. The network's more easily segmented, which improves security. Network resiliency is improved. When we look at leaf switches, if one fails, we're not in any danger. And on the automation side, there's a couple of different ways of doing this. So we have scripting, so using Ansible, Chef, or Puppet to push scripts. That's still done on individual devices though, or else we can look at the SDN way of doing it, and that's what we're going to be looking at when we look at the adaptive cloud fabric. Hold on. Okay, so multi-site fabrics. I'll be very quick here because I think I've gone over. So we've 3 data centers here, and traditionally data center interconnect would get us to the border leaf switch. So even if we did have a fabric, we have a fabric in each one of the data centers, not a multi-site fabric, and that's where Adaptive Cloud Fabric comes in. It's a controllerless solution. Having a controller brings in its own issues, which we'll look at. Single point of failure, obviously costs. You would have to have 3 controllers in each one of these data centers. Business continuity and disaster recovery strategies get simplified. Resource utilization is far better when you think you can actually pool your resources between the 3 data centers and you're not doing it individually. And then obviously workloads can be migrated from data center to data center as there is no boundaries. So Mr. Green here can work here, he can work here, and he can work here just as easily and move his workloads around as he sees fit. So that leads us into Mike going to tell us about the Adaptive Cloud Fabric.